video is about worksheet 2, which involves conversions between moles, molecules, and grams. I've started with number 6 here as an example, and I'm also going to do number 7 as an example. All right, in number 6 here, we have a starting amount. It's 122 grams, and we're being asked how many molecules. Well, we know that the central unit in all of chemistry is moles, so we're going to have to go from 122 grams to moles to molecules. Right. The way that we're going to do that is we're going to use the molar mass, because molar mass connects grams to moles. And we're also going to use the Avogadro's number, 6.02 times 10 to the 23rd. And that's going to connect moles to molecules. All right, dimensional analysis time. Let's put the starting amount over 1. And then we're going to have a conversion. Right, we need to somehow cancel the grams and get to moles. So we're going to need a conversion that has grams on the bottom and moles on the top. Right, we need the molar mass, in other words. We need to know how much 1 mole weighs. Well, 1 mole of copper nitrate, we've got to look up copper on the periodic table, and you've got to go know nitrate. It has an AT ending, so it's on a polyatomic ions list. And then we need to know the charges. Nitrate's charge is -1. Copper, you're actually missing the Roman numeral that you need. The Roman numerals for copper could be 1 or 2. The most common one's 2. So if copper is 2+, then it's going to be CuNO3, 2. If you use a different Roman numeral, if you use copper 1, you'll get a different molar mass and you'll get a different answer, but I wouldn't mark you wrong on the test if I didn't give you the Roman numeral you needed. All right, we need to add up the molar mass of this. Copper has a mass on the periodic table. If you look it up, it's going to be 63.55. So 63.5. And every time you switch an element, you add. So add, open parentheses, nitrogen's 14 plus oxygen is 16, close parentheses, times 2. I didn't use decimals for those two because they're pretty close to whole numbers. When you do all that math out, you get the molar mass, the weight of a mole, and that's going to be 187.5 grams. So it's 187.5 grams per mole. That's the number that goes here. If you didn't use the decimal, it's okay. You can use 188. It won't affect your answer that much. Okay, so if 187 grams or 188 grams is 1 mole, well, what the heck's 122 grams? It's a little less than a mole. When we do the math out, in fact, it'll come out to less than a mole. But the question's not asking us how many moles is 122 grams. It's asking us how many molecules is 122 grams. So we actually have to go one more step. We have to cancel moles and use Avogadro's number to get molecules. So Avogadro's number is equal to a mole, so we put a mole on the bottom so it cancels, just like grams canceled here. And we put 6.02 times 10 to the 23rd particles on top. Right? Particles is another name for molecules. You can use particles instead of molecules. If you use the word molecules, don't abbreviate. You have to use the full word. Not MOL, because MOL looks like moles, and molecules are not moles. All right, that's going to give us an answer. The answer that this gives us is going to be that's not the right answer. Oh, it is 3.92 times 10 to the 23rd particles. And that's the answer, because the particles we're talking about here are molecules. So that's the answer, 3.92 times 10 to the 23rd. I'm also going to do number 7. So number 7 actually is a reverse kind of problem. It starts with molecules and goes to grams. So we're going to want to convert from molecules to moles, which is the center unit of all chemistry, and then convert moles to grams. To go molecules to moles, we're going to have to use that 6.02 times 10 to the 23rd number. That's Avogadro's number. And go moles to grams, we're going to need to use the molar mass. All right. So here we go. Starting amount goes over 1. 9.4 times 10 to the 25th molecules. I'm going to use the word particles because I like to use particles whenever it's molecules or atoms or anything like that. And that's over 1. You'll notice 10 to the 25th is a lot bigger than a mole. So we should get a pretty big number for our answer here. Okay, we're going to want to use that 6.02 times 10 to the 23rd number. This time it's going to be on the bottom because it's that number of particles. And there are 6.02 times 10 to the 23rd particles in a mole. So that's why moles goes on the top. Remember, the top has to equal the bottom of these conversion factors. All right. 6.02 times 10 to the 23rd moles does not equal 1 particle. So that's why these are the right units. You don't use the other. All right. If we stopped here, we'd be in moles. Moles is a great answer, just doesn't answer this question. So we got to go all the way to grams. We need the molar mass to do that. All right. The molar mass of hydrogen gas, well, we need the formula of hydrogen gas. It's not H. H is not the formula of hydrogen gas. Hydrogen is diatomic. It's part of Brinkelhoff, B-R-I-N-C-L-H-O-F. Those are the 7 diatomic elements. Hydrogen is the H. These are the elements that always come in 2s if they're alone. So it's H2 is actually the formula for hydrogen gas. So it's the molar mass is not 1, it's 1 times 2, which is 2 grams per mole. So let's go plug that in. Molar mass. Does 2 grams go on the bottom? Nope, it does not, because grams doesn't cancel moles. 2 grams goes on the top, and 1 mole goes on the bottom. So now moles cancels moles, and parts cancels parts, and then you're going to get your answer. Oh, by the way, 10 to the 23rd cancels 10 to the 25th and leaves 10 to the 2. So that can simplify our math a little bit. All right, when we do this all out, we get an answer of 310 grams. That is rounded to sig figs. If you've got a slightly different answer, make sure to round it to 2 sig figs. So make sure to do that.